Supervolcanoes are ranked by their volcanic explosivity index, which is basically a measure of how much ash they blow into the air. If it's over 8, then we're talking about a real problem, one that could put our entire planet into an ice age or worse. We don't want to find out what worse means, but if supervolcanoes are so bad, why not stop them with geoengineering before they start? Welcome to my channel. Today we're answering the extraordinary question, could geoengineering stop a supervolcano? It's hard to overstate just how awesome volcanoes are. They're magnificent natural wonders. When they erupt, they can be deadly, but humans have learned to live alongside them. Even so, there's a level beyond which we have no desire to live. We're talking about the big ones, the supervolcanoes. You probably heard of Yellowstone National Park's namesake, supervolcano. It's not the biggest in the world, but it's the most famous. It's also potentially the most dangerous because it's sitting pretty close to a lot of people who would rather not die. A few million years ago, Yellowstone was even more active than it is today, having an eruption roughly every 100,000 years. But around 20,000 years ago, things changed and now we're on track for something much bigger. That change has to do with the tectonic plates beneath the North American continent. They're moving around all the time, and that movement causes magma chambers deep within the Earth to become less fluid. As a result, the magma chamber under Yellowstone hasn't moved in 640,000 years. But once it starts moving again, it won't take long to reach its next eruption. And when it does, things are going to get very bad indeed. There are three main dangers from such an event. First, the immediate area would be utterly devastated. Everything within hundreds of miles would be vaporized, and everything within thousands of miles would be buried in ash. Second, the ash itself would cause a global cooling period, known as volcanic winter. As sunlight bounces off the ash clouds, the Earth would be plunged into darkness for months or years. This would destroy crops and cause widespread famine. Third, the sulfur dioxide in the ash would react with water vapor in the atmosphere to form sulfuric acid. This would reflect even more sunlight away from the Earth and cause an ice age lasting decades or longer. To put this another way, a Yellowstone super-eruption would be so catastrophic that we might never recover. The good news is it's not going to happen anytime soon. The bad news is there's nothing we can do to prevent it from happening. Okay, wait, that's actually bad news. Never mind. Well, let's ignore the fact that it would be absolutely impossible to stop a supervolcano eruption. Let's instead imagine that it's possible. How would it work? The first thing you need to know is how geoengineering works. Geoengineering refers to any large-scale intervention in the environment that's designed to combat climate change. There are quite a few methods being discussed, but only a few show any promise. The most popular method is solar radiation management, which aims to reflect more sunlight away from the planet. One example of this is to inject sulfur dioxide into the stratosphere. The particles would reflect light away from the Earth and cool the planet by 1 to 3 degrees Celsius. Another example is to cover 1 to 2% of the ocean surface with small mirrors, which would redirect around 10% of the sun's energy back into space. These are very rough examples, but they'll give you an idea of what's involved. The problem is that these technologies haven't been perfected yet. They're only theoretical solutions based on computer models. So far, the largest geoengineering project ever attempted was the 2019 ESCO-2 geoengineering project, which injected 100 tons of carbon dioxide into the upper atmosphere. Not exactly earth-shattering stuff. But since geoengineering is still in the early stages of development, how could it possibly stop a supervolcano? You see, there's more to volcanic eruptions than just blowing stuff up. A significant amount of heat is released during the eruption, and this causes serious problems. For example, the heat melts rock and soil, causing landslides, mudslides, and lava flows. In the case of a supervolcano, the heat is intense enough to melt entire mountain ranges, leaving behind gigantic scars on the landscape. This melted material is called pyroclastic flow, and it moves at high speeds, incinerating everything in its path. Pyroclastic flow is what destroys everything within hundreds of miles of a supervolcano. In order to stop a super-eruption, Then we need to lower the temperature of the magma chamber before the pressure becomes too great and the whole thing blows. An obvious but terrible solution would be to drop an atomic bomb into the volcano. The explosion would stop the eruption, but it would also release an insane amount of radioactive fallout. Another option is to redirect cold water from the ocean into the volcano. Scientists at the University of Cambridge have explored this idea in detail and found that it might just work. Their plan involved drilling several kilometers into the earth and melting a hole through to the magma chamber. Then they would pump cold seawater into the chamber through a second hole. The seawater would solidify as it came into contact with the molten rock, creating a solid plug that would seal the volcano. Unfortunately, it would take years to complete the process, and we wouldn't be able to save the surrounding area from destruction. If we wanted to stop a supervolcano, we would need to act fast. Another option is to trigger a chain reaction inside the magma chamber. If we could make the magma less viscous, it would eventually flow out of the volcano instead of exploding. Inside the magma chamber, there's a liquid mixture of silicon, oxygen, aluminum, calcium, iron, and magnesium. If we could somehow make the mixture more conductive, then electrical currents would pass through the magma. Those currents would generate magnetic fields that in turn generate electric currents. This is called the dynamo effect, and it's responsible for generating the Earth's magnetic field. By triggering a chain reaction inside the magma, we would eventually create a powerful magnetic field that repels the electrically charged particles in the atmosphere. This would create huge auroras around the volcano. The increased electrical conductivity would also cause lightning strikes, which would eventually turn the magma chamber into a giant lava lamp. The lava lamp effect would eventually drain away all the pressure inside the chamber, and the supervolcano would turn into a normal volcano. As you can probably tell, this is a bit outside the realm of possibility. We don't even know if it's theoretically possible. We would need to inject some sort of seed material into the magma that makes it more conductive. Without that seed material, the currents would dissipate before anything happened. It might be possible to use a laser beam to maintain the conductivity, but that's just speculation at this point. Some other ideas involve changing the composition of the magma itself. Remember when I said that the magma was a liquid mixture of various elements? Well, it turns out that each element has a different melting point. So we could try lowering the temperature of the magma by removing some of the elements. That would require us to drill directly into the earth and suck the stuff out. Or we could try raising the melting temperature by adding something that has a higher melting temperature. This is an easier option, but we would need to add a lot of material to make a difference. For example, let's say we wanted to stop the magma from hardening into a solid plug. In that case, we would need to add a substance with a melting point higher than the magma's boiling point. Otherwise, the added material would simply boil away. We would need to add about 10 billion tons of material to create a plug that would stop the eruption. Where are we supposed to find 10 billion tons of material? I'm glad you asked. Scientists have considered this problem, and they have come up with a rather ingenious solution. There's a place on Earth where there's an almost endless supply of material with a very high melting point. It's called the Mohorovicic discontinuity, or Moho for short. This is the boundary between the Earth's crust and mantle, which lies about 30 kilometers beneath the Earth's surface. It's a very real place that scientists know about, though they haven't been down there to check. Why does it have such a high melting point? Because it's made out of really dense material. According to estimates, there's about 2 times 10 raised to the 18th power kilograms of material at the Moho. If we could somehow scrape a small fraction of that off the top, we would have more than enough material to stuff into the volcano. But how would we actually do that? Well, it turns out that the Moho is weaker than the crust above it, which means we could theoretically drill down and create artificial earthquakes. If we timed it right, those earthquakes would loosen enough material to slide down onto the Moho, forming a massive pile that would cover a huge area. We could then remove the pile with drills and transport it to the volcano, where it would solidify into a plug that stops the eruption. Again, it sounds pretty easy, but it's riddled with problems. First of all, we don't know how the material will react once it's removed from the Moho. There could be unknown forces that stabilize the Moho, and removing the material could have catastrophic consequences for the rest of the planet. Second, we don't know what the material is made of. We believe it's mostly iron and magnesium, but there could be other materials present. This could affect its melting point and make our whole plan fall apart. Third, we don't know how to move the material once we take it out of the ground. It's incredibly dense, so we would need some kind of advanced transportation system to move it quickly. Finally, there's the issue of timing. We would need to remove just enough material to stop the eruption without causing any damage to the surrounding area. That would be incredibly difficult to calculate in advance. And finally, there's the issue of cost. Considering how much material we would need to remove and transport, it's safe to say that this project would be in the hundreds of billions of dollars, if not trillions. And who's going to pay for it? So to answer the question of the title, no, geoengineering can't stop a supervolcano, at least not yet. But who knows what the future may bring? And thank you for watching.